Hello everyone, welcome to my channel. Today we'll discuss the problems of second order derivative. So last day we have discussed about the first order derivative and some of the important problems. Today we'll discuss about second order derivative. So we'll start with a question. So question number 1. So first question is here. It is given like this. Y equals to log x plus root over of x square plus 1. Now prove that, now this is given, we have to prove that 1 plus x square plus 1, x square plus 1 d2y dx2, and that will be d2y dx2 plus x dy dx equals to 0 plus x dy dx equals to 0. Okay, so it is given y equals to log x plus root over x square plus 1, and we have to prove x square plus 1 d2y dx2 plus x dy dx equals to 0. Now this is the problem of second order. So for second order derivative, how to solve? So first, same thing, you have to find the first order derivative. After that, you have to find the second order derivative. So first it is given y equals to this one. That means we have to differentiating both sides with respect to x. So that will be dy dx, and here you can see this is log. So what is the derivative of log? Derivative of log is 1 by x. That means here it will be 1 by the whole thing here. What is here? X plus root over of x square plus 1. This is the derivative of log. Now into, now inside the log, this is a function x plus root over x square plus 1. So derivative of x, what is the derivative of x? 1 plus, there is a square root. What is the derivative of square root of x? Square root of x is 2 root x, 1 by 2 root x. Remember this one, derivative of root x. Okay, last day we have mentioned that one derivative of root x is 1 by 2 root x. You have to remember this one. So here we can see derivative of root x square plus 1 will be 2 into root over of x square plus 1 into, this is a chain rule, there is x square plus 1, so x square derivative will be 2x and plus 1, that will be 0, like this. Done. Now 2 and 2, that will be cancelled out, so it will become like this, 1 by x plus root over of x square plus 1, and it will be 1 plus x by root over of x square plus 1, like this. Now here we can see this is 1 plus x by root over x square plus 1. You have to simplify this one, you have to do the LCM. So it will become like this, it will be 1 by x plus root over of x square plus 1 into, if I do the LCM, the LCM will be here root over of x square plus 1, that will be root over of x square plus 1, and here it will be root over of x square plus 1 plus x. Now you can see both are same, so this one and this one will be cancelled out. So from here we can write dy dx equals to 1 by root over of x square plus 1. Now this is the first order derivative, dy dx equals to 1 by root over x square plus 1. Now to prove that one, look at the proof. This is d2y dx2, that means we have to do the second order derivative. Now for the second order derivative, we have to remember one thing is that whenever there is a division form, we have to make it to multiplication form first, and second one we have to remember is that if there is any root term, square root term, we have to square both sides. So first of all, you can see there is a square root term, so that means we have to square both sides. That means it will become dy dx whole square, that will be 1 by x square plus 1. So whenever there is a square root form, we have to square both the side. Okay, so to remove the square root. The next one is whenever there is a division form, we have to convert it to multiplication form. So we know this is a division for 1 by this one, so we have to multiply like this. Okay, so multiply x square plus 1, so it will become x square plus 1, that will be dy dx whole square equals to 1. Okay, so remember this one. For this type of proof, whenever there is a division, we have to convert it to multiplication form, and if there is a square root, we have to square the both side to remove the square root. Okay, so it will be easier then. So now do the derivative here. So it will be what? Now if I do, now differentiating both side with respect to x. So now we have to differentiate both sides with respect to x. Now look, whenever I differentiate this one, that will be product form u, and this is the v here. So this is the u and this one is the v. So the same thing, uv form. So what is the form? First, derivative of x square plus 1. So derivative of x square plus 1, that is 2x, and that one will remain constant. That means dy by dx whole square, that will remain constant. Plus, now next one will be what? Next one will be u is constant, that means x square plus 1, that will be constant, and we have to find the derivative of this one, dy dx whole square. Now since this is a whole square, so there will be a chain rule. So whole square, that means take this one as x, so x square. So what is the derivative of x square? That is 2x. That means 2 dy dx. Okay, so this is the derivative of the square, and then inside of this one there is dy dx. So what is the derivative of dy dx? That will be d2y dx2. Okay, d2y dx2. Now equals to here there is 1. So we know what is the derivative of 1. Derivative of 1 will be 0, like this. Now from here you can see 2x. Now look here, there is a 2, there is dy dx. So here also there is 2 dy dx. So we can take 2 dy dx. So from here it will be x dy dx plus x square, that will be dx2. Okay, so x square plus 1 d2y dx2. Now it can't be 0. 2 dy dx is not 0 and 2 is also not 0. Now from here, that's why you can write like this, x dy dx plus x square plus 1 d2y dx2, that equals to 0. So that is the proof here. So this is the proof. Okay, so look at here, same thing it came. So it is x square plus 1 dy dx d2y dx2 plus x dy dx equals to 0. So here also you can see x square plus 1 d2y dx2 plus x dy dx equals to 0. So this is the way to prove this type of problems for the second derivative. So one thing we have to do is the first, if the problem is given, first find the first order derivative. Then after the first order derivative, if there is any square root of term, we have to remove the square root by squaring both sides. Next is, if there is a division form, we have to make it to multiplication form. Then you can do the derivative again. Okay, so this one you have to, this step you have to remember. So here like this we will get the result. And one thing is that derivative of again I am telling that one, derivative of dy dx whole square. What is the derivative of dy dx whole square? So first look at this, this is a dy dx, so we can take as x. So this is x square. So x square derivative is 2x. So here x is dy dx into dy dx derivative will be d2y dx2. That one you have to remember. Okay, so dy dx derivative will be 2 dy dx into d2y dx2. That is the way to solve this type of problem. So we move to next one, question number 2. So now question number 2. So look, the question number 2 is as follows. So it is given x equals to, so it is given x equals to tan 1 by a log y, this one. Okay, so x is given tan 1 by a log y. Then prove that this one we need to prove that 1 plus x square, okay, 1 plus x square, that is d2y dx2, then it is d2y dx2 minus 2x minus a, that is dy dx equals to 0. Okay, so it is given x equals to tan 1 by a log y. Then prove that 1 plus x square d2y dx2 minus 2x minus y dy dx equals to 0. So this one we need to prove. Again, I can say this is d2 by dx2, so this is a second order derivative. So same thing. So look at here, first it is x equals to tan of this one, so tan is there. Now if tan goes there, it will become like this: tan inverse of x equals to 1 by a log y, like this. Okay, now differentiating both sides with respect to x. Okay, now we will differentiate both sides with respect to x. That means tan inverse of x, it will become 1 by 1 plus x square equals to 1 by a into log y. Log, what is the derivative? 1 by y, into derivative of y will be dy dx. Okay, so that will become like this. That will be 1 by 1 plus x square equals to 1 by a y dy dx. Okay, so that will come like this: 1 by 1 plus x square, 1 by a y dy dx. Correct. Now first derivative done. So next step is that whenever there is a square root, you have to remove that one. So there is no square root, so there is no square root, so there is no case of removing the square root. And one thing is that if there is division formula is there, if there is any division, make it to multiplication. Now you can say this is the division 1 by this one, this is 1 by this one, so just cross this one. Okay, cross multiply this one, so that will become what? That will be ay equals to 1 plus x square dy dx, like this. Okay, now if ay goes there, that will become like this: 1 plus x square dy dx minus ay equals to 0. Now if we do the derivative here, 1 plus x square dy dx, look again, now we have to differentiate with respect to x on both sides. Now if I differentiate, this is the u and this is my v, so this is v and this is the v. So how to differentiate? So same thing, first 1 plus x square, the differentiation will be 2x and dy dx will be same, plus now 1 plus x square will be same, derivative of dy dx, that will be d2y dx2, minus a into differentiation of y will be with respect to x, that will be dy dx equals to 0. Done. So from here you can see, if I write arrange properly, that will can be write like this: 1 plus x square d2y dx2 plus, now here we can see 2x dy dx, here also it is minus a dy dx, so that will be 2x minus a dy dx, so that will be the proof. Okay, so here that will be the proof. So in the question some error is there. In the question it will be plus instead of minus. Okay, so 1 plus x square d2 by dx2 plus 2x minus y dy dx equals to 0. So this is the way we have to solve this type of second order derivative. So same thing we have done. What we have done is that first we have done simply first order derivative. After the first order derivative, since there is a division form, we make it to multiplication form. Then second order derivative, after arranging that one, we get the result. Okay, so it's very simple, this one. Now next is question number 3. Okay, question number 3. So question number 3 is like this: it is given y equals to e to the power tan inverse of x. Okay, so it is given y equals to e to the power tan inverse x. Then prove that, we have to prove 1 plus x square d2y dx2, okay, d2y dx2 plus 2x minus 1 dy dx equals to 0, this one. Okay, so e to the power tan inverse x is given, we have to prove 1 plus x square d2 by dx2 plus 2x minus 1 dy dx equals to 0, this one. So again the same thing you have to do. First what we need to do is find the derivative of this one, so that will be dy dx. Now e to the power something, e to the power x, we know the derivative is e to the power x, that means e to the power tan inverse of x into derivative of tan inverse x, that is 1 by 1 plus x square, like this. Okay, So e to the power tan inverse x into derivative of tan inverse x is 1 by 1 plus x square. Now this 1 by 1 plus x square, so it can be written as like this: e to the power tan inverse x by 1 plus x square, and this is what? Dy dx. Now again the same thing, if there is any division form, we have to make it to multiplication form. Now we can see here, this is the division form, e to the power tan inverse x by 1 plus x square. So just cross this one, okay, cross multiply. So that will become 1 plus x square dy dx equals to e to the power tan inverse x. Now what is e to the power tan inverse x? The value of e to the power tan inverse x is y. So instead of e to the power tan inverse x, we can write y here. Okay. So same thing, 1 plus x square dy dx equals to y. Now the proof is here d2y dx2. That means there will be a second order derivative. So again we have to do here second order derivative. So if I do second order derivative, this is the u and this is the v. So again differentiating both sides with respect to x. So that will be 2x dy dx plus 1 plus x square, okay, and that will be d2y dx2 equals to, and derivative of y will be dy dx. Now if dy dx come here, so this is the same 1 plus x square, it will be 1 plus x square d2y dx2, okay, plus it is 2x dy dx minus dy dx equals to 0. So that will be 1 plus x square d2y dx2 plus that will be 2x minus 1 dy dx equals to 0. Done. Now this is the proof. Okay. So this is the way to prove this type of problem. So here you can see this is the proof. 2x minus 1. So you can see 1 plus x square d2y dx to 2x minus 1 dy dx equals to 0. Okay, plus 2x minus 1 plus, yes, 2x minus 1 dy dx equals to 0. So this is the way we can solve. Now move to next one, number 4. Okay, same logic. Every question is we can do with the same logic. So again question number 4, we can see it is given y equals to sine inverse x. Okay, y equals to sine inverse x. Then we have to prove that. Okay, we have to prove 1 minus x square d2y dx2 plus 2x minus 1, not 2x minus 1, sorry, 1 minus x square d2y dx2 minus x dy dx equals to 0, minus x dy dx equals to 0. Okay, so y equals to sine inverse x is given, and we have to prove 1 minus x square d2y dx2 minus x dy dx equals to 0. So here again we have to do the same thing. So first find the differentiation here. So that will be dy dx, and sine inverse x will be 1 by root over 1 minus x square. Now again there is a square root. If there is a square root, we have to square both sides. Okay, square both sides. That means it will become dy by dx whole square, and that will be 1 by 1 minus x square, like this. Now again, since there is a division, you have to make it to multiplication form. So it will multiply there. So that will be 1 minus x square dy dx equals to 1. So this is coming 1 minus x square dy dx equals to 1. Now from here dy dx whole square, sorry, dy dx whole square equals to 1. Now it is the correct form. Now we have to differentiate again with respect to x. Okay, so this is the u and this is the v. So again same thing, we have to differentiate this one, that will be minus of 2x, because derivative of 1 is 0 and x square is 2x, so that is minus 2x, and this one is dy by dx whole square plus, now next one is 1 minus x square derivative of dy dx whole square. So dy dx whole square is 2 dy dx into d2y dx2, and derivative of 1 is 0. So from here we can see 2 dy dx is a common element, so I am taking 2 dy dx. So here it will be minus x dy dx plus here it will be 1 minus x square d2y dx2 equals to 0. Now dy dx can't be 0 here, so from this we can write like this: 1 minus x square d2y dx2 minus x dy dx equals to 0. So this is the proof here. So 1 minus x square d2y dx2, yes, x dy dx. Okay, correct. Then this is the proof. Okay, so same logic, same thing, we are doing the same thing, we get the result. And the last one, question number 5, we'll do the last one, question number 5. So this is the question. So first question number 5 is like this: y equals to, suppose, a cos log x, okay, a cos log x, and this is b sin log x, something like this will be given. And we have to prove something in second order. A proof will be there given, so we have to prove that one. Okay, so this is the function y is given, and from this we have to prove something in second order. One statement will be given, we have to prove that one. So for that one, what we need to do, same thing, first find the first order derivative. Okay, so first we have to find the first order derivative. So first find the first order derivative, that will be dy dx equals to, now look at here, this is a is constant. Now cos is here, minus sign, so that will be minus a sine of log x. Okay, and log x, the differentiation of log x is 1 by x, that means that will be x only. Done. Now plus b sine, differentiation of sine is cos, so that will be cos of log x, and differentiation of log x is 1 by x, so that will be x only. Okay, now again, since there is a division, x is there, so first LCM that one. So if I LCM that one, that will be x, and that will be minus a sine of log x plus b cos of log x, like this, and there it is dy dx. Now since this is a division form, again the same thing, if this is a division form, we have to make it to multiplication form. So here x is divided, so x will be multiplied there, so it will become like this. It will become x of x into dy dx equals to, x into dy dx equals to minus a sine log x minus a sine log x plus b cos log x. Okay, b cos log x. Done. Now this is the multiplication form. Now we have to differentiate again with respect to x. Okay, differentiate with respect to x both side. So if I differentiate that one, that will be, here you can say this is the u and this is the v, so uv form. So what is the form? First derivative of x, that will be 1 into dy dx plus x into derivative of dy dx, that will be d2y dx2 equals to minus, look, this is sine, so that will be a cos log x, and derivative of log x is 1 by x. Done. Now next one is b, and there is a cos, derivative of cos is here sine, so b sine log x, and log x derivative will be 1 by x. Done. So it will be x d2y dx2 plus dy dx, and the denominator will be like this, x, and that will be minus a cos log x, okay, and minus b sine log x, like this. So if I multiply, now this x will be multiplied here, so it will become like this. It will be x square d2y dx2 plus x square d2y dx2 plus x dy dx equals to, now look at the right hand side. Now this right hand side is similar as this one, y. Okay, uh, look at here, the right hand side. Right hand is minus a cos log x minus b sin log x. That means, look at here, this is equal to this one. So this is what? Minus y. So here it can be written as, if I this can be written as minus y. So minus, if minus y comes here, it will be x square d2y dx2 plus x dy dx plus y equals to 0. Hence this is the proof. Okay, so this is the way to prove this second order derivative. So second order derivative is very easy. First you have to do the first order derivative. Now next one, to prove the second order derivative, if there is any division form, make it to multiplication form. If there is any square root, we have to square both side, then do the second order derivative, then we'll get the result, whatever result is been asked. Okay, so this is the process to do those type of sums. So that's all about the derivatives. In the next classes we'll discuss some problems, some typical problems of derivative and integration and so on. So thank you for today.